Hello kids! In this video, we're going to learn about forces. The children are playing tug of war. Both teams are pulling equally hard and they are not moving. What are the directions of the forces applied by the two teams? How do the forces act? A force is a push or a pull acting on an object. How do we measure force? We use a spring balance to measure force. Force is measured in newtons. Look at the diagram above. It shows a force of 6 newtons is used to pull the block of wood. Do you notice the red arrow in the diagram? What does it show? We use an arrow to the direction of the force acting on an object. In this picture, a force is acting on the rope to the left. In the second picture, a downward force is acting on the plastic pump bottle. The length of an arrow shows the magnitude of the force acting on an object. The longer the arrow, the greater the force. Who is exerting a greater force? The father or the son? Resultant force. An object may have two or more forces acting on it at the same time. These forces can have different magnitudes and directions. We can add them up to get the resultant force. The resultant force is the single force that has the same effect on the object as all the individual forces acting together. If two forces acting on an object are in the same direction, the object will move in the same direction as the forces. The resultant force is the sum of the two forces. For example, two forces, 4 newtons and 6 newtons, are acting on the box in the same direction. The box will move in the same directions as the two forces with the resultant force of 4 newtons plus 6 newtons equals 10 newtons. If two forces acting on an object are in the opposite directions with force A being greater than force B, the object will move in the same direction as force A. The resultant force acting on the object will be the difference between the two forces. For example, a force of 2 newtons is pulling the box to the left and a force of 5 newtons is pulling the box to the right. The resultant force is 5 newtons minus 2 newtons equals 3 newtons. The box will move in the same direction as the greater force that is to the right. If a force of 14 newtons is pulling the brick to the left and a force of 5 newtons is pulling the brick to the right, what is the resultant force acting on the brick? In which direction will the brick move? Draw an arrow to represent the resultant force in the diagram below. 14 newtons minus 5 newtons equals 9 newtons. If both forces are acting equally on an object in the opposite directions, the object will not move. The resultant force is 0. In a game of tug-of-war, if both teams pull equally hard, both teams do not move, making the game a draw. The forces are balanced and acting in the opposite directions, thus canceling out each other. On the other hand, when Team N pulls harder than Team N is being pulled toward the marker, making Team M a winner. The forces are unbalanced and do not cancel out each. When we kick a stationary ball, it will roll, then slow and eventually stop. What makes the ball stop rolling? When the ball rolls on the ground, the surfaces of the ball and the ground are in contact. There is a force acting in the opposite direction of the rolling ball. This force slows down and eventually stops the ball. This force is known as friction or frictional force. So the red arrow stands for directions of the rolling ball, and the blue arrow, the directions of the friction. Friction acts in the opposite direction of the movement. It occurs when two surfaces rub against each other. Here are some examples of friction in our daily activities. The friction between the shoe sole and the ground allows us to walk without slipping. Pushing force from the shoe sole on the ground. The red arrow is the friction. The friction between the sofa and the floor makes it difficult to push the sofa. Pushing force, then the friction. Here are some examples of friction in our daily activities. The friction between the tire tread and the road prevents the car from slipping, especially on rainy days. The blue arrow is the directions of the moving car, and the red arrow is the friction. There is friction between the body of the boy and the surface of the slide. How will the flowing water affect the movement of the boy down the slide? Directions of the boy sliding down the slide. And the red arrow is the friction. Can you draw the direction of the friction involved in each of the activities below? Direction of the drawer being pulled. Friction. Direction of the moving bicycle. Friction. Factors affecting friction. Friction depends on the texture of the contacting surfaces. The rougher the two surfaces are, the greater the friction between them. Do you notice that it is difficult to pedal a bicycle on a field than on a cement floor? The field has a rougher surface compared to the cement floor. Therefore, the friction on the field is greater. Thus, we need to pedal harder on the field to overcome the friction. Friction also depends on the weight of the object. The heavier the object is, the greater the friction acting on it. A heavier rock needs a greater force to move it. This is because the friction between the heavy rock and the floor is greater. On the other hand, we can move a lighter rock easily as the friction between the rock and the floor is smaller. Advantages of friction. Friction allows objects to stay still on the table or on the ground. After some toy blocks are stuck up, they will stay still and do not fall. Why? We can carry out a lot of our daily activities with the help of friction. Frictions allow us to hold objects. The pencil in the hand does not slip easily. The friction between the hand and the pencil prevents the pencil from slipping. Friction allows objects to move without slipping. The friction between the shoes and the floor prevents us from slipping. What prevents a moving car or motorcycle from slipping? Friction gives out heat. We can light a match by striking it against its box. Friction sharpens and smoothens the contacting surfaces. Friction between the blade of a knife and a whetstone helps to sharpen the blade. Friction stops moving objects. The friction between the gloves and the ball stops the ball. How does a moving car stop? Disadvantages of friction. There are a few disadvantages of friction. Friction wears out the contacting surfaces. Therefore, shoes and tires are easily worn out. A worn-out shoe sole. Friction also slows down all moving things. Therefore, the engines of a ship work extra to keep the ship moving against the friction. Friction not only wears out parts of engines or machines, but also produces heat. The heat can damage the sensitive parts of the engines and machines. Engines of a car. Thanks!